Hey everybody, I want to look at another example that illustrates multiplicity a little bit more, and just another reminder that we should always remember to check that when you find your horizontal or oblique asymptote to see if the curve crosses it. So in this case, everything's been factored for us, and so we can go ahead and just begin with the domain. So the domain is the set of all x such that x cannot equal 0 and 4. Okay, because here's where it cannot equal 0, and here's where it cannot equal 4. And the x-intercepts are going to be 1 and -2. X equals 1 and -2. And so here we want to note this has multiplicity 1, and this one has multiplicity 2. And so again, what this is telling us is similar to polynomials, that the curve, the rational expression, the rational function is going to cross x equals 1 because it has multiplicity 1. And the rational function, when it crosses, it's going to bounce off -2 because the multiplicity is 2. So when you're in the numerator, it's like a polynomial, so follow that same pattern. And we do not have any y-intercepts. And the vertical asymptote is going to be x equals 0 and x equals 4. And this one is going to have multiplicity 1, and this one's going to have multiplicity 2. And so what this is similar to is when the multiplicity is 1, it's similar to the reciprocal function 1 over x. And so in that, when x is getting close to 0, the curve is going to opposite infinities. So anytime the multiplicity is 1, you can expect that opposite infinity style. It may not be like exactly like this because it could be switched. It depends on other information in your function, but that's kind of some more reasoning of when the multiplicity is 1, you're thinking about it in terms of 1 over x. When the multiplicity is 2, we're thinking of the reciprocal squared function, which looks like this. I think of the Atari symbol. And what's happening is that as x is getting, for the 1 over x squared function, as x is getting closer to 0, the curve is approaching the same infinity. So around x equals 4, the curve is approaching the same infinity because the multiplicity is 2. All right, and then let's look at our horizontal asymptote. The degree of the numerator is x squared times an x, so x cubed. And the degree of the denominator is another x squared times an x, so x cubed. So that means that the horizontal asymptote is going to be y equals 1. So now we want to check to see if the curve crosses the horizontal asymptote. So we need to solve 1 equals, and we need to start multiplying this out. Well, let's just take our time. X minus 1, x plus 2 squared over x times x minus 4 squared. So we'll want to begin by multiplying both sides by x times x minus 4 squared. And so we'll have x times x minus 4 squared equaling x minus 1 times x plus 2 squared. We need to multiply all this stuff out, so I'm going to end up with x times x squared minus 8x plus 16 equals x minus 1. It's better to multiply this first, or you have to, order of ops. So x squared plus 4x plus 4. So distributing this, we'll end up with x cubed minus 8x squared plus 16x equaling x cubed plus 4x squared plus 4x minus x squared minus 4x minus 4. Let's see what we can clean up. So there's an x cubed on each side. Say goodbye to them. And you have your negative 8x squared plus 16x equaling 3x squared minus 4, 4x squared minus x squared, so 3x squared, and then the 4x and minus 4x cancel, so 3x squared minus 4. Okay, so we have a quadratic equation. I like to have the leading coefficient positive, so I'm going to add 8x squared to both sides and subtract 16x. So we'll end up with 0 equals 11x squared minus 16x minus 4. I'm not confident that this is going to be factoring. I don't want to complete the square because I would need to divide by 11, and that seems like I would have a lot of nasty fractions. So I'm going to go ahead and use the quadratic formula. Alright, so I've rewritten our problem so we have more space. Let's go ahead and use the quadratic formula. This is going to be x equals 16 plus or minus the square root of negative 16 squared minus 4 times 11 times negative 4. Let's extend that square root. All divided by 2 times 11. And so I'm coming up with, when I punch this into my calculator, 16 plus or minus square root 432 divided by our 22. And so these come out to approximately negative 0.217 and 1.672. This means, so all this work, what this is telling us is that another point on our graph is going to be negative 0.217, 1 and 1.672, 1, because this is where the curve is going to cross the horizontal asymptote at these ordered pairs. So at this point, we would probably need to do make the sign chart to see where the curve is above or below. But I'm gonna go straight to the graph and show you kind of how else we can think about this. So let's go ahead and put in our horizontal asymptote and our vertical asymptote. So our horizontal asymptote was at y equals 1. Come on. The vertical asymptote was at 0 and 4. And then 1, 2, 3, 4. And let's go ahead and put in our x-intercepts. There was one at 1, 0. And another one at -2, 0. And we also have those points that where it crosses the horizontal axis, the horizontal asymptote. So -0.217, so really close right here, and 1.672, so around here. All right, so remember this one has multiplicity. Whoa. What the heck? Oh my goodness. What the heck? Okay, there we go. Whew. This one has multiplicity 2. So this means that the curve is approaching the x equals 4 from the same infinities. And then at this x equals 0, it's going to be approaching from opposite infinities. And so since we have a point here, and we know, let's take a step back, because this one's also going to have multiplicity 2. No, at 1 it's multiplicity 1, so it has to cross. And the only way it can cross is to get to that point. So that's automatically telling me that the curve has to do this. It's not a really good sketch. So it's coming in, and it's looking something like that. I wish I had, okay, there. Now, so like you kind of have to play like hunt for like those cues to put the pieces together. And so now, since I know that this has multiplicity 2, and this is already coming to positive infinity, and there's no other x-intercepts or crossing of the horizontal asymptote, that this side must look like this. And since we know that this is the horizontal asymptote, the curve must get really, really, really close to it, but it has to bounce off this point here because it has multiplicity 2. So it's going to come in, and then boop, and then pass through that point, and then go all the way up to your vertical asymptote. And so that's the sketch. Okay, so if it's kind of hard to do that, you can always just, go ahead and go over here and try your -2, -1, and 4 to figure out if you're above or below. But I always like to just play that game to see if I can not necessarily use this approach. Alright, I hope you found this helpful.